Welcome back to my channel once again. So today we will be discussing the CBSE board grade 9 topic Heron's formula. So in the previous 3 videos I explained the Heron's formula and we have also solved some problems. So this is the final part of the Heron's formula that I am going to explain to you. So here we will be solving more problems of using the Heron's formula. Okay, so let's take a look. The first question is, a triangle and a parallelogram have the same base and the same area. If the sides of the triangle are 26 centimeter, 28 centimeter and 30 centimeter and the parallelogram stands on the base 28 centimeter, find the height of the parallelogram. So here what is given, that the triangle and the parallelogram, they have the same base and also they have the same area. So let's take a look at the how it will look like. So you can clearly see that one triangle and one parallelogram, they are standing on the same base, right? They are having the same base. Now the sides of the triangles are given 26, 28 and 30 centimeter. So here, since it is mentioned that parallelogram, it stands on the base 28 centimeter. So 28 centimeter will be the base one. And we can take 26 in the other side of the triangle. And the third side will be 30 centimeter. Now this is the parallelogram which stands on the 28 centimeter base. Now we need to find the height of the parallelogram. So height means the perpendicular distance on top of the base, right? So the highlighted orange one is the triangle. So since we have lanes of all three sides of a triangle, so let us first find its area using Heron's formula. So for triangle, we know that one side is 26, that is A, B is equal to 28, and finally the C is 30 centimeter. So semi-perimeter, because we know the Heron's formula is square root of S into S minus A into S minus B into S minus C. So semi-perimeter will be half of A plus B plus C. So if we calculate, then 26 plus 28 plus 30 divided by 2. So which is coming, if we add it, it is coming 84 by 2 means 42 centimeter. So now we need to find the area of the triangle by using the Heron's formula. So area of triangle would be square root of S into S minus A into S minus B into S minus C. Now put all the A's and A value, S minus A value. 42 minus 26, 42 minus 28 and finally 42 minus 30. So it is coming 42 into 16, 42 minus 26, 16, then 42 minus 28, it is 14 and 42 minus 30 is 12. Now do the prime factorization. 42 means 2 into 3 into 7. Now do the prime factorization of 16, that is 4 into 4. Here we have taken 4 into 4. Why? Because we can also make it in terms of 2 into 2 into 2 into 2. But since we know 16 is basically square of 4. So we will make the pair. We are trying to make the pair over here. Now 14 is basically 2 into 7 and 12 is equal to 2 into 2 into 3. Now we will try to figure out the pair. So we are taking 2 pair. So 2 will come out. Whenever we make the pair, that will come out of the square root. 3 is making pair, so it will come out. 7 is also making pair, so it will come out. Now 4 is making pair, so it will come out. That 2 is making pair, so it will come out. Okay, so we have covered everything. and we can see this is a perfect square. So area of triangle will be, if you multiply, it will be 336 centimeters square. Now since the triangle and parallelogram have the same area, so the parallelogram area will be also 336 centimeters square, right? So now what is the formula to find the area of the parallelogram? So that is the base into height. So we know here the base is 28. So 28 into height is equal to 336. Now put those values. Now we will get the value of height. 336 divided by 28 is coming height equal to 12 centimeter. So this is the final height of the parallelogram, that is 12 centimeter. Okay, now let's move to the next question. A rhombus-shaped field has green for 18 cows to graze. If each side of the rhombus is 30 meter and its longer diagonal is 48 meter, how much area of grass field will each cow be getting? Okay, so let us take a look at the question first, then we need to draw the diagram. So what is given? A rhombus shaped field has green, that green field is there, means there is a grass over there where the cows can graze. So there are 18 cows. So this is a type of a rhombus figure where the cows can graze. You can see the green figure, green field over there. Now let us name it as ABCD. Now we know the properties of rhombus, that in rhombus all the four sides are equal, right? If each side of the rhombus is 30 meters, so side is given and its longer diagonal is 48 meter. So each side means AB, BC, CD and AD all are 30 meter each. And the longer diagonal is AC, let us consider it as AC, is 48 meter. Okay. Now how much area of grass field will each cow be getting? So the area of grass field each cow will get is equal to, so you can see clearly, in this case we have considered the diagonal as AC. You can take the diagonal as that other side also, DB also. Okay, so whatever you are taking, you can clearly see that the diagonal is dividing the rhombus into two triangles, right? So now that is equal to the total area of the field. Now how many cows are grazing over here? That is 18 cows, right? So for each cow, how much area will each one will get? That is the total area of the field divided by 18. That we need to find out. Each cow, how much the area they are getting. So that is equal to total area divided by 15. Sorry, not 15, 18. Now we know the diagonal of the rhombus divides it in two triangles of equal areas. So this property you already know, that it is dividing the rhombus into two equal triangle, right? Now we have to find the any side, any triangle. We can either find the triangle ADC or triangle ABC. Okay. So let's find triangle ADC. So triangle ADC, we know all the three sides over here. So we can apply the Heron's formula over here. So for triangle ADC, A equal to 30 meter, B equal to 48 meter and C equal to 30 meter. So let's find the semi-perimeter, that is A is equal to AS into S minus, sorry, A is equal to A plus B plus C divided by 2. Okay. So that is equal to 30 plus 48 plus 30 divided by 2. Now that is coming 108 by 2. So if you divide, it will come 54 meter. Okay. Now by Heron's formula, the area of triangle ADC will be equal to square root of S into S minus A into S minus B into S minus C. So that is equal to 54 into 54 minus 30 into 54 minus 48 into 54 minus 30. Okay, now let's do the calculation. 54 into 24, then 54 in minus 48 will be 6, and 54 minus 30 is again 24. Now let's factorize it. 54 we can write as 3 into 3 into 6, that is 9 into 6. 9 means 3 into 3. And let's take that 6 together. Now we keep the 24 with, there are pair of 24, so we'll keep that pair time together. Okay. So now we can see that we are getting each number a pair. So 3, so if it will come out, then 6 will come out, then finally 24 will come out. So the final area will be 432 meters square. So what will be the total area of the field then? Total area of the field is equal to 2 into the area of triangle ADC, because we know that triangle ADC and triangle ABC is same. So it will be the double. So 2 into 432. So that is equal to 864 meters square. Now this is the total area. So how much each cow will get the area? That will be total area divided by 18. So 864 divided by 18. That is equal to 48 meters square. So the final answer is area of grass field each cow will get is 48 meters square. Okay, so now let's move to the next question. Find the area of a quadrilateral ABCD whose sides are 9 meter, 40 meter, 28 meter and 15 meter respectively. And the angle between the first two sides is a right angle. Okay. So let's take a look at the question. So the figure is given. So it's if the figure is not given, you have to draw the figure based on the question given. Okay, so if you check, this is the quadrilateral where the angle between first two sides is a right angle. So one angle is 90 degree and all the sides are given over here. Okay. So now this is the quadrilateral ABCD. So let ABCD be the quadrilateral and all sides are known, that is 9, 40, 28 and 50. Now first two side is a right angle, it's given. So ABC is perpendicular to AB. So that means angle ABC is 90 degree. So as quadrilateral ABCD is an quadrilateral, we don't have any formula to find its area. So why it is telling that since we don't know any formula for finding the quadrilateral, we only know the formula for rectangle or parallelogram, right? Or square, but we don't know the area to find the quadrilateral. So let's take a look how we are going to solve this problem. So now let us divide this quadrilateral into two triangles by drawing diagonal AC. But we know that whenever we join the diagonals of a quadrilateral, it will divide the quadrilateral into two triangles. So let's join this. So now let us start with the right angle triangle ABC. Okay. So here base and height is given. So now what is the formula to find the area of right angle triangle? That is half into base into height. So let's apply that formula over here. So triangle ABC area will be equal to half into base into height, that is equal to half into 9 into 40. So that is half into AB into BC, and that is 9 into 40. Correct? So now that will be 20 into 9, that is 180 meters square. So we find the value of the area of triangle ABC, that is 180 meters square. Now we need to find the area of triangle ADC. Okay. But To find the area of triangle ADC, we need to know the length of all the three sides, that is DC, AD and AC. Now here we only know two sides, but we don't know the third side, that is AC. So let us find the length of AC over here. But if we take a look at triangle ABC, in triangle ABC, AC is this basically the opposite side of the right angle. So that is called the hypotenuse. So now we can easily apply the Pythagoras theorem over here. So AC square equal to AB square plus BC square. So that is AC square equal to 9 square plus 40 square. So it is 81 plus 1600. So 1681. So AC will be equal to square root of 1681. If we do the square root of it, we will get 41 meter. Okay. So now we got AC equal to 41 meter. So this how to find the square root, you can, earlier I showed you how to find the square root of using division method. In multiple videos I showed you how to find the square root of a particular number. So you can apply that division method over here and find the square root of 1681. So which is coming 41 meter. Now consider triangle ACD. So that will be equal to, in this case, now we know all the three sides A, B and C. Now we need to find the semi-perimeter rays, that is equal to A plus B plus C by 2. So let's put the values over here. And finally we got 1 by 2 into 84, that is 42 meter. Now we have to apply the Heron's formula over here to find the area of triangle ADC. So that is equal to square root of S into S minus A into S minus B into S minus C. So the area of triangle will be equal to, triangle ADC equal to 42 into 42 minus 41, then 42 minus 28, then we have 42 minus 15. So which is 42 into 1 into 14 into 27. Now 42 means 14 into 3. Since 1, we can see why we have taken 14 over here. Since we got 140, we can see that there is 114. So we have to get another 14 to make a pair. So then 3 will come out from here. And 27 means 3 into 3. Now if we rearrange, 14 and 14 is making a pair. So it will come out. 3 and 3 is making a pair. So it will come out. And another 3 and 3 is making a pair. So it will come out. So the final answer will be triangle ACD is 126 meters square. Now to find the area of quadrilateral ABCD will be area of triangle ABC plus area of triangle ACD. So that is equal to 180 that we already got earlier plus 126, which is equal to 306 meters square. So the final answer is area of quadrilateral ABCD is 306 meters square. Now let's move to the next problem. Find the area of a trapezium whose parallel sides are 25 cm, 13 cm and other sides are 15 cm and 15 cm. Okay. So the two parallel sides are given as 13 and 25. And the other sides, that means the non-parallel sides, are 15 and 15. So that means it is a isosceles trapezium because non-parallel sides are equal over here. So this is called the isosceles trapezium. Now let us take a look. Now let ABCD be the given trapezium in which AB equal to 25 cm, CD equal to 13 cm, and BC equal to 15 and AD equal to 15 centimeter. So now what is the formula for the area of trapezium? That is half into sum of the parallel side into height. So here we don't know the height. So we need to find the height over here. So let us draw a perpendicular line CF on top of AB. Now for finding length of CF, we need one more construction. Let us draw CE that is parallel to AD. Okay. Otherwise, we will not be able to find the CF. So now, since we draw CE parallel to AD and AE is parallel to CD, that is already given, right? So we can clearly see that that quadrilateral ADCE, that is a parallelogram. Opposite sides are parallel. So we know that in parallelogram, opposite sides are equal, right? So in this case, AE equal to DC equal to 13, and similarly AD equal to CE equal to 15. Now consider AB over here. In segment AB, that is made up of two segments AE and EB. Now AB equal to AE plus BE. So AB we know, AE also we got. Now we can easily find the value of BE. So BE will be 25 minus 13, that is 12 centimeter. Now consider triangle BCE. So in triangle BCE, first we need to find the area of triangle BCE using Heron's formula, because now we know the three sides of the triangle. So let's put the value over here. First we need to find the semi-perimeter, that is a plus b plus c by 2. So that is 15 plus 12 by 2. This 42 by 2 means 21 centimeter. Now area of the triangle will be S into S minus A into S minus B into S minus C using Heron's formula. So area of triangle BCE will be equal to 21 into 21 minus 15 into 21 minus 15 into 21 minus 12. Now 21 into 6 into 6 into 9. Now 21 means 7 into 3. 6 and 6, then 9 means 3 into 3. So the area of triangle BC will be, now 6 is a pair, so it will come out, and 3 is also pair, so it will come out. So 6 into 3 is 18, square root of 21 centimeter square. So that is what we got. We can name it as equation 1. Now for triangle BCE, we have the area and base. Now how we can find the height? We know another formula, that is area is equal to half into base into height for a triangle, right? So if we put that, we can easily find the height. So area of triangle BC is half into base into height. So we know the area over here. Now put the base value, then we can get the value of the height. So CF will be equal to 18. So 18 root 21 is equal to 6 CF. So CF will be 18 root 21 by 6, that is 3 root 21 centimeter. So CF we got. Now height of the trapezium ABCD is same as that of triangle BC, right? That is also the height of trapezium. So now what is the formula to find the area of the trapezium? That is half into AB plus CD into CF, that is half into sum of parallel sides into height. So area of trapezium will be half into AB plus CD into CF. Half into AB is 25, CD is 13, and CF is, we already got 3 root 21. So half into 38 into 3 into root 21, it is 57 square root of 21 centimeter square. So this is the final answer of the area of the trapezium. Okay, so now let's move to the next problem. A hand fan is made by stitching 10 equal side triangular strips of two different types of paper. The dimensions of equal strips are 25 centimeter, 25 centimeter and 14 centimeter. Find the area of each type of paper needed to make the hand fan. Okay, so this is the hand fan look. So where we have 5 strips with the same pattern and the next 5 strips with the alternate we have the another pattern. So two types of paper strip is used over here, and each are forming one triangle, and the triangular strip, the sides are given over here. So we need to find the each type of paper used, like the square one and the other pattern, how much paper is required to make this fan. So for finding the area of each type of paper, first we will find the area of the hand fan. So hand fan is made up of 10 triangles. So area of hand fan will be equal to area of a triangle multiplied by 10. So to find the area of each type of paper, we will divide the area of hand fan by 5 because there are only two types of paper. So 10 divided by 2 since we have two types of paper over here. Now let us start finding area of a triangle using Heron's formula. So we know that Heron's formula is square root of s into s minus a into s minus b into s minus c. So for triangular paper strip, let a equal to 25, b equal to 25 and c equal to 14 centimeter. So the semi-perimeter will be a plus b plus c by 2. Now let's find the value of it, which is 32 centimeter. So now the area of the triangle will be s into s minus a into s minus b into s minus c. Let's put the values over here now. So 32 into 7 into 7 into 18. Now 32 means 4 into 4 into 2. And 18 means 2 into 3 into 3. Now let's make the pair. So the final answer we are getting for the triangle is 168 centimeter square. But the hand fan is made by stitching 10 equal triangular strips of two different types of paper. So area of each type of paper needed to make the hand fan will be 5 into the triangular strip area, that is 168 centimeter square. So which is coming 840 centimeter square. So the final answer will be area of each type of paper needed to make the hand fan is 840 centimeter square. Now moving to the next problem. A triangle and a parallelogram have the same base and same area. If the sides of the triangle are 13 centimeter, 14 centimeter and 15 centimeter and the parallelogram stands on the base 14 centimeter, find the height of the parallelogram. So both the triangle and parallelogram have the same base and also they have the same area. And in triangle the sides are given. And we know for parallelogram it is based on the base 14 centimeter. And we need to find the height of the parallelogram. Since we have lengths of all three sides of a triangle, let us first find the area of the triangle using Heron's formula. So that is equal to square root of s into s minus a into s minus b into s minus c. So for triangle a equal to 13, b equal to 14 and c equal to 15. So now let's find the value of s, that is a plus b plus c by 2, which is coming 42 by 2, that is 21 centimeter. Now the area of the triangle will be square root of s into s minus a into s minus b into s minus c. Now put all these values in the formula. So that is 21 into 21 minus 13 into 21 minus 14 into 21 minus 15. So 21 into 8 into 7 into 6. So 21 means 7 into 3. 8 means 2 into 2 into 2. And finally 6 is 2 into 3. Now let's make the pair. So now it is coming, the area of the triangle is 84 centimeters square. But we already know that the area of triangle is equal to the area of parallelogram. So this is given. So area of the parallelogram will be also 84 centimeters square. Now the base of the parallelogram is given 14. But what is the formula to find the area of the parallelogram? That is base into height. Now put that value. So area of parallelogram equal to base into height. So 84 equal to 14 into height. So height will be equal to 84 divided by 14. So which is coming 6 centimeter. So the final answer is height of the parallelogram is 6 centimeter. Now next, solve the next problem. Find area of rhombus whose perimeter is 80 meter and one of the angle is 60 degree. Okay, so let us draw the diagram of the rhombus. So in rhombus we know that all sides are equal and one angle is given over here, that is 60 degree. So since we know the perimeter, so perimeter here is the perimeter of that rhombus PQRS is 80. So perimeter will be 4 into one side. So 4 into PS. So PS will be 80 divided by 4, that is 20 meter. So we know the side of the rhombus now. Now let us divide the rhombus into two triangles by drawing the diagonal PR. But we already know that the diagonal in a rhombus, the diagonal divides it into two equal triangles. So the area of rhombus PQRS will be equal to 2 into triangle PSR. So now let us find the area of triangle PSR. But if you take a look, triangle PSR, PS equal to SR, that means it is an isosceles triangle. So in triangle PSR, PS equal to SR equal to 20 meter. Now if you take a look, since PS and SR is equal, so angle SPR is equal to angle SRP because they are the angles opposite to the equal sides and that should be also equal. So let us consider it as X. So angle SPR plus angle SRP plus angle PSR equal to 180 degree by angle sum property of the triangle. So now replace the values. This is X, SRP is also X and PSR is 60 degree. So now 2x equal to 180 minus 60, that is 120. So x will be equal to 60 degree. So what we got is all the angles are 60 degree. So that means triangle PSR will be a equilateral triangle. Now what is the area of the equilateral triangle? That is square root of 3 by 4 into side square. So we have to apply that formula. So area of triangle PSR will be square root 3 by 4 into 20 square. So that is square root of 3 by 4 into 400, that is 100 root 3 meter square. Now we already know that area of rhombus will be twice of triangle PSR. So now put the value over here, 2 into 100 root 3. that is 200 root 3 meters square. So finally the answer is area of the rhombus is 200 root 3 meters square. So that's all for today. So we have come to the end of this Heron Formula chapter. So there are total 4 parts. This is the last fourth part we have explained. So in the previous 3 parts, I have already provided the video. So if you haven't watched yet, so please go through those videos first, then come to this video. Otherwise, it will be difficult for you to understand. So we have completed the Heron's Formula chapter entirely. So if you have any doubt, you can go back and watch it again. Still, if it's not clear, you can put it in the comment section your doubt, and I will try to explain that. Or I will try to come up with a new video to explain your answer. If you like this video, then please hit the like button and please share it with your friends so that they can also learn from this video. And to get other videos, upcoming videos notification, you need to subscribe to my channel. Then for that, you just press the bell icon and you will get notified whenever any new videos will be coming up. So that's all for today. Thanks for watching once again. Bye bye.